everyone, in this exercise, let f from a to b be a function. We want to prove that f is bijective if and only if for any subset u of a, f a set minus u is equal to b set minus fu. Again, the proof here is not very complicated, yet it will be very interesting to see how the concepts of injectivity, surjectivity interplay with those of the image and pre-image under set operations. So let us first work on the only if part by assuming the function f is indeed bijective. From there, let u be an arbitrary subset of a. We have f a set minus u is equal to f a set minus fu. In other words, the image of the set difference is equal to the set difference of the images. Be careful, in general, this does not hold. Indeed, the set difference of the images, in general, can be properly contained in the image of the set difference. Yet, here we have the equality thanks to the injectivity of f. Keep going from there. Now, let us apply the surjectivity, which basically indicates that fa is precisely the set B. Let us also recall that in general, this is not true, as fa, the range of the function, might be a proper subset of the codomain B. And here, the equality is precisely due to the surjectivity. As a consequence, we end up with b set minus fu, which is precisely the desired identity. Next, let us turn to the if direction by assuming that this set equality holds for arbitrary subset u of a. From there, we want to show that the function f from a to b is indeed bijective. Let us use the proof by contradiction for this part by assuming that f is not bijective, which means either f is not injective or f is not surjective, and we will try to reach a contradiction for each of these two cases. So let us assume to the contrary that f is not injective, which means that we will be able to find two distinct elements x1, x2 in A, such that fx1 is equal to fx2. Since the given set identity works for an arbitrary subset u of A, let us take u to be the singleton set consisting of only x1. Now, on the one hand, since x2 is not equal to x1, x2 is not in u. Yet x2 is in A, thus x2 is in A set minus u. From there, fx2 is in the image of A set minus u by the definition of the function image. On the other hand, x1 is in u. Thus, again by the definition of function image, fx1 is in fu. Naturally, as a consequence, fx1 is not in B set minus fu. However, by our assumption, these two sets are the same sets. Moreover, fx1 and fx2, they are the same element. Thus, you can't have an element which belongs to the set and does not belong to the set at the same time, which is a contradiction. As a consequence, we conclude that f must be injective. Next, let us assume that f is not surjective, which means that there exists some element, let's say y star in B, which is never achieved by any element in A under f. With this assumption in hand, let us now choose u to be set A itself. That is, we choose u to be the whole domain. Now let us look at the given set identity. This time, the left-hand side becomes f A set minus A itself. In other words, this is the image of the empty set, which should also be empty itself. Yet the right-hand side is clearly not empty, as it contains at least the element y star. So again, we have reached a contradiction, which in turn implies that our assumption is false. In other words, f must be surjective. Now that f is both injective and surjective, we conclude that f is bijective.